In this video, we will continue with compound angle formula. You will find this on page 442 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Now we are going to focus on the formula for cos a plus b and cos a minus b. Okay, but let's first see how did I derive it. Okay. Complementary angles. Now, don't forget, we are going to make use of this, and I even showed you, this was on page, I just want to see the page, I think it's 181, I just want to check in chapter 4, on page 181, just want to write it here. This is on page 181, in chapter 4. We learned, and we had this triangle. So this is 90, and this is theta. Because it must add up to 180, then this will be 90 minus theta. Okay, so I can either stand there, or I can stand there. So if I say sin here, okay, can I show you another thing? This is the x value, this is the y value, and this is the radius, r. Okay. So if it's sin, and I'm standing here at the green, then it's opposite over hypotenuse. So it's x over r. But if it's cos, and I'm standing at theta, then it's adjacent over hypotenuse. And did you notice that this is then exactly the same? So therefore, this will be equal to this. And the same, if I go cos, and I'm standing here, then it's adjacent over hypotenuse, so y over r. And if it's sin, then it's opposite over hypotenuse, so it's y over r. And again, did you see that this is the same as this? And then tan, I'm standing here, opposite over adjacent, and then cot will just be the reverse. So this will be equal to this. But in this, we are going to make use of this principle. So I took this, I went and go to page 181, and you will see it there. Okay, so keep this in mind. So if it's sin, and I'm standing at 1, then it's cos. Or if it's cos, then it's sin. But every time it's the 90 minus theta. So we have the formula. This is now coming from this sin, the compound angles. So we have this. So we write it down. Now replace A. Okay, so every time you see A, replace it with 90 minus A. Okay, so I replace 90 minus A, 90 minus A, 90 minus A. Now then I simplify. Now this is just 90 minus, and if I want to put a bracket there, I must change that to a positive. So this is A plus B. Now, what is sin 90 minus A? So sin 90 minus theta, or A, will just be cos. So in the place of this, okay, let's just say, okay, did I already place it in here? Sin 90, no, I didn't place it. I did it in this step. So it's cos A, and there is the cos B. And then if it's cos, no, then it's sin. Okay, and there is the sin B. Did you see? So I replace this with cos, and I replace this with sin. And now I have this formula. This is my first one. I want you to take notice. Do you see that there was a positive, and then this one changed? Why did it change to a negative? Can I just show you? Because this was just because of the A plus B. That's why it changed. Do you see? So I was just taking that. Just like I was taking theta, I just took A plus B. But just take note, the signs are different. And I want to show you on the, okay, I'll show you now on the formula sheet. Let's first do the second one. So now replace B by negative B. So every time I see B, okay, I replace it by negative B, negative B, negative B. So it's cos A minus B, and this is going to be cos. Okay, now you must not forget, you are on your cos diagram. Can I just show it to you? Don't forget, like in the previous. You are there. Now, cos negative b means it's in a negative direction. Don't forget your cost. Now, what is cos here? It's positive. So this will change to positive cos b due to the cos diagram. Now, what is sin negative? That's negative. So basically, can I just show you there? This becomes negative sin b. And then a negative times a negative will change into that positive. Okay, do you see? And now basically when it becomes a negative again, I want you to take note of that, then it was a positive. Okay, and also, did you see it's not sin, cos, it's cos, sin. Cos A and then B, sin. But I want to show you this. I derived it now, but you will also find it on the formula sheet. I took this out of the example of a formula sheet. Now, if you look here, can I just show you where you will find it? There's the compound angles. There's there was the sin one, and here. And did you notice they will show it on the formula sheet like this? Do you see that on top was the positive, and then at the bottom was a negative. And then when it was positive on top, it was negative. Positive top, negative, and then it was positive. And with negative goes, so it's the opposite signs, where positive goes with positive, negative goes with negative. But here positive goes with negative, and negative goes with positive. And it's not alternative, it's first the cos and then the sin. Okay, but you can check it out on your formula sheet that you will get in a test or in an examination. Okay, let's look at another very interesting thing. Now, I'm going to show you this. This is the special angles in the unit circle. So I actually took it in quadrant 1, quadrant 2, quadrant 3, quadrant 4. You can memorize it, okay, because it's a very easy way then to find all your special angles in the different quadrants. Okay, but I also will show you how did I come to it. Now, I want you first, before I think it would have been good if I first wrote this on top. I should have actually first put this part there, totally on top, so that you just understand it as soon as you look. But otherwise you can see the picture and then you can just start. Okay. Now what does it say to you? It says, you know that cos, okay, remember, so if you have a triangle, and I'm going to first make the triangle. Okay, let's just make a triangle there. Now, if you have a triangle, don't forget, I just want to get my pen, that this is your x value, this is your y value. A unit circle, the radius will always be 1. Always. That's the radius, but that will be equal to 1. So if you have cos, you're standing here, then it's adjacent over hypotenuse. So it's x over 1, and this is what I'm showing you, x over 1. So actually, because of it's over 1, cos theta is just x. If it's sin, if you're standing here, then it's opposite over hypotenuse. So it's y over 1, which is actually just sin theta is y, okay? Now, this is the two important. Now, if you have a coordinate point, in a coordinate, because this is in terms of coordinate points, what in a coordinate point, first comes the x, then comes the y. Okay, in a coordinate point. Now, I said this x represent cos theta. That means in the coordinate point, and actually this will be cos theta. That will be the ratios of cos theta. And then will be the ratios of sin theta. Okay, so, and I'll show you now. I'm going to take this one, the one I marked here. Now, and I'm also going to use my special triangles. I draw it also here, but let's just go and I want to explain it in one in this quadrant, one in this quadrant, one in this quadrant, one in this quadrant. Okay, so I really want you, because this is what you're going to use in further mathematics. Okay, so let's just start. let's just, oh, I don't like not working with a ruler in this. This is now, remember, this is my 30 and 60. And then I have an isosceles, okay, maybe like this. Okay, let's just write it in. So in this case, this was, remember, an equilateral. So if it was an equilateral, this was 60 and this was cut in half, so this is 30. Don't forget, in terms of this is pi over 6 and this one is pi over 3. And then it was an equilateral, so that was 2. And because it's cut, this is 1 and this is square root 3. Okay. Because Pythagoras theorem. I take the long square minus this, so it's 4 minus 1, and that's the square root of 3. Now, so that's for the 30 and the 60, or pi over 6 and pi over 3. Now, for this one, don't forget that, or remember every time this is 90, 90. Now, this one here, this is, if it's isosceles, then it's 1, 1, square root 2. And then it's going to be, okay, let's just write it in. This is going to be pi, or 45, over 4, or 45 degrees. And this is the same. This is 45, or pi over 4. And there is your, oh, 3. This is your special angles. So this one, and make it a little bit lower. So this one is for the 30 degrees and 60 degrees, and this is for the 45. And there is your different pi's. Okay, now let's start. This is pi over 4. If I'm working out, I first want to just explain this, and this is what I showed you there. If I'm working here, and I want to now, on my special, now don't forget, if this is 30, it means there is 30. And there, oh, this is 90, and that is 60. Now, if you want to work, okay, I don't need the 60. I just need the one to the x-axis, 30. I just want that one. I want to make it in red that you see better. This is 30. Now, if you think of this special triangle, 30, what is cos? It's adjacent square root 3 over 2. Do you see there? Square root 3 over 2. What is sin? Sin, I'm standing at the 30, is opposite over hypotenuse. So it's 1 over 2. And there you got it. So without drawing this, I can just, if I memorize this, I can just, okay, it's going to be square root 3 over 2, and this is going to be a half. Okay, but you can also work it out. So this is now, so in this one, it's actually very easy because there's all is positive here. You cannot forget your basic thing, and I'm going to write it, I want to write it in a color that stands out. You cannot forget your cost diagram. You have to bring your signs in, and that's why this is going to help you. Now, say for example, and I'm going to take again the 30. I will now do, say I'm doing this one. I will show you now. Now, what will 30 be here? If this was now 30, the real angle is from here to there. So it's 180 minus 30, which is actually 150. So if I see in an exam, say for example, I see, and I want to make it white, if I see cos, and you must think of chapter 4, 150. Now, I must actually think, how can I write it in terms of the acute angle? It will be cos 180 minus 30. And then what did I do in chapter 4? I was thinking, where is it? It's in the second quadrant. Now, what is cos in the second quadrant? That's negative. So it was negative cos 30. So basically, it's still going to be, just like, I didn't write it here, but what was cos 30? Cos 30 was square root 3 over 2. But now it will be negative square root 3 over 2, which you see there. Negative square root 3 over 2. Okay, and now what was, and let me just try to fit it in here, what was sin 30? Sin 30 was opposite over hypotenuse, that was a half. Do you agree? That was a half. But what would be, but sin, what is sin in this second quadrant? It's positive. So if I want to write sin 150, it's going to be sin, I do it exactly just like in chapter 4. That's why you must be very good in chapter 4 before you go to chapter 10. Okay, so it's going to be 180 minus that 30 degrees. And now I have to think, oh, second quadrant. So it's going to be positive sin 30 degrees, which is also, what is sin? Opposite over hypotenuse, so it's 1 over 2. So in this case, and if you look here, it's going to be a positive. So it was negative positive. So in this quadrant, if 30 was there, now let's go on with the 30. We're not going to work it out again. What will the next one be? 210. Right, let's just draw it there. Do you see? 180, 210. So it will be exactly the same. Do you see? It's exactly the same. So you actually just have to memorize this and the signs. But then you're just going to say, okay, now if it's exactly the same, it's also 30. So it's still going to be square root 3 over 2. But what is cos in this quadrant? It's tan's quadrant. So cos is negative as well as sin is negative. Do you see? So it stays the same. It's just your signs that will be negative. Oh, I want to rather make it red. Negative, negative. And now, where will it be here? Do you agree? It will be here. So it's exactly the same there. But in this quadrant, cos will be what? Positive. Do you see? And what will sin be? What is, it's not sin's quadrant. There is sin's quadrant. So sin will be what? Negative. So do you see, I use the same values, and I'm going to make it green. There it's positive. There I must think of my cos, but the values is the same. Just the signs can differ. There, do you see there? And there, it's the same. I must just think of my signs. Do you see? And that's just an easy way. I'll show you now tan. But I first want to finish, okay, maybe let's go to tan. Because I have no sin, and I have cos, or cos and sin, but how will I find tan? And this is what I explain here to you. How do you get tan? So if I say tan 150, I will now go in radians. Now, tan is going to be sin 150. Don't forget sin must be on top. And again, you can see it. I want to just take you to that. I'm bringing it in. I could have bring it in earlier. But do you see on your formula sheet, you will see that there. There is that. So you will find it. It's very good to memorize it and to know it, but you will also find it on the formula sheet. Okay, so this is sin 150. And what is this? This is cos 150. And then I'm just going to say, okay, sin, so this is what is sin? Sin was a half. Let's just fill it in. What was cos? It was square root. First keep your signs like this. And this is actually meaning a half multiplied 2 over square root 3. And it cancel, and the answer is 1 over square root 3. Okay, and now let's check it. What is tan 30? Because it's going to be tan, do you agree? If I tan 30, it's opposite over adjacent, so it's 1 over square root 3. Did you see that? So it's 1 over square root 3. And again, if I must work tan, in this quadrant, it will be positive. In this quadrant, it will be negative. In this quadrant, it will be positive. And in this quadrant, it will be negative. Okay, and that's how I bring it to the whole 4 quadrants. I just want to do another one. I said all of you, but I just want to do another one in terms of radians. Because sometimes, and I'm going to clean it, and then I'll show you exactly the same again, and I'm just working in radians, and I just take another angle. And maybe I'll take the 45. Okay, and again, I want to clean this. And I want to just, okay, I could have maybe just left my cast. Okay. Now, let's start with tan 45. I think that 60 was working almost the same. So let's take tan 45. There it is. Okay. I just want to clean this also. And now, tan 45, I start in this quadrant. Now, remember, what is tan? Tan is, this is not a good one because tan is going to be opposite over adjacent. I don't want to find tan. Tan is easy. I'll show you now. I want to start with cos because remember, the first one represents cos theta, or in this case, cos 45. And then the second one, sin 45. Yeah, that will make more sense. Okay, so let's start with cos 45. Yeah, no, I don't want to work with 45. Sorry, I'm correcting myself. I'm in radians. So it's going to be pi over 4. So cos, doesn't matter if I stand here or there, this is going to be the same. So cos is going to be adjacent, okay, are you with me, over hypotenuse, or there, adjacent over hypotenuse. So it's 1. But in this, over square root 2. In this diagram, because we work in further mathematics, we always rationalize the denominator if there's a square root in the denominator. So we will say square root, and we will do it like this. And that's square root 2. And then square root 2 times square root 2 is 2. Okay, let's just check. Do you see? There is cos. Okay. Now, what is sin? It's a nice one. What is sin? Let's just check it on my diagram again. Just get my pen correct. What is sin? Pi over 4. So sin is opposite over hypotenuse. So it's again 1 over square root 2. And if I rationalize it, okay, then I will find square root 2 over 2. I want you to check. So what did you square root 2 over 2? Before I go to tan, now, what will pi over 4 be in this quadrant? Okay, I'm in radians now. So, this is going to be now, remember, it's almost like to find that value, can I just show you here? You're just going, because of course, remember this is pi. So, it's like you say pi minus a quarter pi, or pi over 4. And what is that going to be? That's going to be 3/4 pi. So where is it? It's there. Do you see that? And if you draw that, it's going to be exactly the same as that. But now you must just think in this quadrant. Remember, it's always first, in this, it's always first your cos and then your sin. So cos in this quadrant is going to be negative. And what is your sin in this quadrant going to be? Positive. And if I go further, what is, now I want to find it in this quadrant, then I'm going to say it's pi over 4, pi, plus a quarter pi. And what is that going to be? So it's 1 1/4 pi. But if I write it as improper, it's 5 over 4 pi, or 5 pi over 4. And where is it? There it is. Do you see? And again, if I go and I must find these values, I want to show you again. But now, there it is. Let me first show you. There it is. It's exactly the same as there, but now you must think, in this quadrant, what is cos, what is sin? So in this quadrant, both of them, because only one that's positive is tan, is going to be negative. Did you see that? Okay, and then in this one, can I just show you, and for that one, it's going to be 2 pi. For this one, we're going to work with the 2 pi. 2 pi minus pi over 4, or a quarter pi. And now, what will that be? 1 3/4. Do you agree? And if I make it improper, you will see it improper there. It's going to be 7 over 4 pi. I can also write it. So where is it? There. Do you see? And can I show you again? If you go up, there's my values. There's my values. Exactly the same. But again, I have to think. In this quadrant, what is cos? Where am I? What is cos? Cos is going to be positive. And what is sin going to be? negative. Did you see that? And if you memorize, so you don't have to memorize actually everything. You can just memorize this 3. Remember, this is 30, 45, 60, or pi over 6, pi over 4, pi over 3. And then you just bring in the signs. This is exactly the same, just different signs. The signs can basically. And if you do that, then it's very easy. So if you know the sin and cos of 1, so in this case, if I want to go to the tan, okay, let's just go. I want to show you. So in the tan was very easy. Do you agree? And this was that one I showed you, because it would have been sin divide cos, so it would have been square root 2 over 2 divide square root 2 over 2, which would have been cancelled and which will be equal to 1. Okay, so and then if I ask you tan in this quadrant, positive. Okay, tan in this quadrant, negative 1. Tan in this quadrant, positive 1. Tan 7 pi over 4, okay, let me write. Yes, 7 pi over 4, then this would have been negative 1 again. Okay, and this is very, very useful. So please try to memorize that. It's just going to help you very fast. And if I'm going to go on in the examples, I'm going to make use, I'm going to come back, I'm going to bring in the signs, and just because it's usually, because it's very challenging, you struggle to finish. And the more you know and the faster you can recall things, the faster you're going to work in the exams. Okay, that's why I was bringing it in. Okay, now you are ready for an example. I said so much, and now I can do an example with you. I'm going to make it a little bit bigger, that you see better. Okay. Now I'm going to use this too. The cos A plus B, cos A minus B. Now find the values of the following without using a calculator. Okay. Now remember, it's like the reverse. Do you see cos, cos, sin, sin? You remember that will be the positive will go to a negative. Okay. So basically I can just say 75 minus 50. I always go to the special angles because it's like working without a calculator. So it's cos 60. Okay. Now I want to show you quickly. If you were I want to, because I'm bringing this in. So cos 60, if you were thinking, and I'm going to just make space so that if I work now, that you can see. Okay, if I want to write now something new, then it's a little bit clean. Okay. Okay. So if I say cos 60, so there is 60. Do you agree? I memorize, so what is cos? Because I know it's first cos and then it's sin. So cos is a half and it's in this quadrant, so it's positive. So let's just go back. Sorry, I think, yes, I just want to leave the special triangles. Sorry, I'm going to just bring it back. I want to clean, but I want to leave the special triangles. The nice thing is I can reverse here. Okay. Okay, so, and if I even look here, cos 60, adjacent over hypotenuse, but I could find it here, or I could have said cos, and I just know it's a half. Okay, let's go on. So it's a half. Now, cos 105, now we'll go forward. So I think again, remember I work with 30, 60, 45. So what will it be? 60 plus 45. But now I have to use my compound angle rule. So it's cos 60, cos 45, and remember to change the sign from a positive to a negative. Sin 60, sin 45. Okay. Now, I'm just going to, I just took this out of the special triangle and I want to show you. So I have cos 60 yes, actually I'm taking just the 61. Just go and the 45. 60 and the 45. Let's go back. So I recall the 61. I will show you now. So there's the 61 I recall, and I recall the 45. Because with that two values, I can find cos, and I can find sin, and I can work out tan. Okay, it's not necessary, but okay. So this is what I showed you. So from the special triangles, I have, okay, let's just see, okay. let's go to cos 60. Just want to see cos 45. Oh, I just wrote it like this, but I prefer that we go to the original. So cos is a half. Do you agree? Okay, so it's going to be that half. What is cos 45? Let's go back. Cos 45, it's square root 2 over 2. Square root 2 over 2. Okay. Minus, what is sin 60? Remember, sin is the second one. So it's square root 3 over 2. Again, you can do it here. You can say sin of 60 is opposite over hypotenuse, which is exactly the same as that. Okay. So square root 3. And then what is sin 45? And again, I go back. So sin, remember, it's the second one. So square root 2 over 2. No, sorry, I'm too much. Okay. And then basically, I just simplify the denominators, and that's my final. So I use the unit circle. Okay. In this case, I just wrote it down, but I think it's better to recall it like this one, cos and sin. And then to recall the 45 one also. Yes, this is the 45. There's this cos one, and there is the sin one. Okay, now I'm going on, and the last one, now I work in terms of radians. Now, this is a bit more challenging than the degrees sometimes, so please just, and especially this one. And I want to show you what I do to make it easier. Because if I look, and look at and I'm going to make it smaller, that you first see better. Okay. I know my different ones in terms of radians. Okay, I'm in radians. I know I have, let's start with 30. So 30 is pi over 6. I know that 45 is pi over 4. I know that 60 is pi over 3. Okay. Now I look. This is 90. Okay, first let's make the denominators to 12. And I'm going to write, so it's times 2, times 2, times 3, times 3, times 4, times 4. This is going to be, okay, this is 2 over 12. 2 pi over 12. This is going to be 3 pi over 12. And this is going to be 4 pi over 12. Okay. Now, I want to show you. Because it's 12, that's the 12. Otherwise, if it was not 12, I will make the denominator. Say it was 5, I will make it to that. Okay, but it's 12. Now I check. 4, 5, 6, 7, 8, 9. I will not come to 19. So I have to double something. So if I'm looking at this one, I can maybe say, okay, 19. Okay, I can go to 9 and 10. Because this one, do you agree that this one, because where is now this one? This one. Oh, where am I? Yes. This one, I can go to 9. And this, which one will go? And this one, I can go to 10. Do you agree? Because if I have 9 plus 10, I will get 19. Okay. But what must I do with this one? To go to, because it must 3 times as big. Do you agree? So this was just to help you. Okay, just to help you. But this is 3 times. So I will times it with 3. Then it will be 9. And this one, I will times it with 5. Do you agree? To be 10. So this was actually 3 times 3, which is 9. 2 times 5, which is 10. Okay. So I'm going to work with this too. But, so I'm going to, you can work with the original one, which is pi over 6. And I times it with 5. And it's going to be pi over 4. And I times it with 3. Okay. So this, because it's 5 times as big, this is going to be 5 pi over 6. And this is going to be 3 pi over 4. Are you with me? If you make the denominators the same again, can I show you? Multiply 2, multiply 2. Multiply 3, multiply 3. You will get 10 over 12, and you will get 9 over 12, which is 19 over 12. Okay, now you must think, where is 5 pi? So this is what I'm working with, 5 pi over 6 and 3/4. Now, 5 pi over 6, where is it? It's 1/6 less. If you go to your this, go and look. 5 pi over 6, I found it. It's there. It's 1/6. Do you see it? Okay, let me rather say it now. Let's take that line away. This line is 1 over 6. Do you agree? So I'm going to work with pi over 6. But this is the ratio that I work with. Because in this quadrant, this will appear. And then, let's go back. I'm going to work with 3/4, so it's minus 1/4. Do you agree? Okay, so let's go to 3/4. Okay, where is 3/4? There is my 3/4. Do you see? And I'm going to work with that. So if I know my unit circle, I can just remember this is cos sin. So don't forget, in this quadrant, cos will be negative, and in this quadrant, cos will be positive. This is exactly the same. Can I just show you here? This is going to work with this one. Let's just make it red. And this one, the signs will just, the values are the same. The signs will just, the cos will be negative, and this one. Okay, so let's go back. And this is what there I showed you. Okay, and now I can basically, first use your rule. That is how I came to that 19 over 12. The rule is cos, first one, second one. If that is a positive, then this is a negative. Then sin, first one, second one. And then I just go, in this one, don't forget that this represents cos, sin. Okay, let's rather make another color. This is also cos, and this is sin. Okay. So then I can just basically write it down because I have my cos. What is my cos of 3/4 there? And what is my cos of 5 over 6? There is my cos. And then I have my sin. Now I'm with the blue ones. So my sin, and then I have my sin, and I just fill it in. So this was my red ones. This, it's not allowed. Red ones. This was my blue ones, and I just simplify, and that's my answer. Okay. This is usually not, I will not say the way, but it's like a preparation to where we go, and it's like advance of what we did in chapter 4. Very, very good for further mathematics. Okay. I want you to stop the video, and I really want you to take your time to try your best to go to the unit circle and to do number A as well as number C. And again, as soon as you are finished, check the video, continue with the video. But first try to do it on your own. If you have to, it was a long video, but if you have to check the first part 2 times, do it so that you get familiar with this. I'm going to make it a bit bigger. Okay, I think I can start here. Okay, let's start with the first one. The degrees is always a little bit easier than the radians, but the more you work with radians, and especially in further mathematics, the easier that also will become. Okay, so here's like the reverse of the rule. Okay. So I'm going to start with the rule, and I'm just going to say this is going to be equal. This is the cos one, always remember. And this is going to be because I'm trying to get 65. I'm trying to either get 30, 45, 60, but I can get 90 and 180 also. So in this case, it's going to be 65. Don't forget, if that's a negative, then this is a positive, 25. And that is going to be cos 90, which is very easy. And I said it in chapter 4. It's for me very, very important that you always recall the basic graphs. Because with the basic graphs, to get 90 and 180 is so easy. So what is the basic graph of a cos It's like this. And there was 360. And in the middle was 180. So this is 90 and this is 270. So what is 90? 90. So it's going to be 0. So my answer is just going to be 0. You can check to see on the calculator if you are correct. Make sure your calculator is on degrees then. Okay, now we come to the next one. The next one is again we have to find that combination, and that is very important. Okay. And again, I'm going to do it very long. I'm going to show you step by step, just like I did in the other one, how to get that. Okay, let's start with number C. Okay, so in this one, it's going to be cos 11 pi over 12. Okay. So in this one, again, I must first get that combinations. Now, just like I showed you previously, let's just go a little bit to the side and let's just think. I have pi, that color is not good for me, make it yellow. I have pi over 3, pi over 4, pi over 6. Okay, I prefer making the denominators the same, then I can compare. So times 4, times 4, times 3, times 3, times 2, times 2. So this is also equal to 4 pi over 12 plus 3 pi, again, actually no, over 12, plus 2 pi over 12. And again, I'm going to just make lines because I'm going to rather. Okay. And then I'm going to just think 4 plus 3, 7. No, it's not going to work. I have to think to double something. Okay. So if I maybe multiply this one, okay, 4 times 3, it will be too much. But if I say 3 times 3, do you agree? If I multiply this one with 3, then I get 9. My pen is not correct. Then I get 9. And then 10, 11. Then I can use this one normal. Okay, so this one I will times with 3. So I'm times, this was just to help me. So I times there with 3. So I'm getting 3 pi over 4. Do you agree? And this I didn't times this one. And it's 1 pi over 6. Okay. Because if you then make the denominators again the same, you don't have to. I'm just doing it a little bit long. I think you can find it easier. So then it's 9 pi over 12 and 2 pi over 12. 9, 10, and that's 11. So basically, it's, okay, can I write cos, okay? And then what did I say? Remember, I'm there. So it's 3/4, oh, actually there, you can just take that. 3/4 pi plus pi over 6. Okay. And then it's going to be cos 3 pi over 4. I'm using the rule now. Cos pi over 6. Don't forget the sign must change in the cos, so it's negative sin 3/4 pi sin pi over 6. Okay. And now I go to I'm going to now go to my unit circle. And I'm going to look for 3/4 and pi over 6. Okay, now let's first go to, I'm taking this from the unit circle. And I'm going to write, I just want to make a space. Let me just go a little bit there, because I want to write it there. I don't want to make it so small. So I'm going to just clean here. I showed you that. And I'm going to use this. You can also just do it on the side. Okay. So it's 3/4. So where is 3/4? It's 1/4. So it's this one. It's this blue one. Can you remember? And it's in this quadrant. So cos will be negative sin. So it's square root 2 over 2. Can I just show you? So I'm taking, where am I now? Yes. It's going to be, let's just say 3 pi over 4. In my unit circle, it's going to be square root 2 over 2. Okay, now what is cos in that one? It's going to be negative. Do you agree? And sin, what is sin? It's also going to be square root 2 over 2, but it's positive. Let's just make sure. So it was square root 2 over 2 negative and positive. Okay, and now, and also pi over 6. Can you remember? The other one was pi over 6, this one. And this one was square root 3 over 2.5. You can work with that also. I just want you to get used to this one. So square root 2 over 2.5. Okay. Square root 3 over 2.5. So square root 3 over 2.5. And that is pi over 6. And this is coming from the unit circle. Just another nice way of remembering it. Okay. And this is in quadrant 1, so both will be positive. Okay. Don't forget that this every time first is cos and then is sin. Okay, now I can fill it in. Okay, so cos, I'm above cos, what is it going to be? It's going to be negative square root 2 over 2. There it is. Then it's cos still, so multiply square root 3 over 2. Then it's sin 3/4. So what is it going to be? There. So it's square root 2 over 2 multiply sin 1/2. Okay, and then I'm just going to simplify. Let's go for the finals. Oh, so nice. So this is going to be, remember chapter 1, search, this is why I showed you. So it's square root 6 over 2. And this one is square root 2 over 4. Oh, sorry, this is not 2. Sorry, maybe you picked it up. So this is 2 times 2 is 4. I thought square root 2, incorrect. So square root 2 over 4. Okay, this was my, there is a negative. And then it's going to be negative square root 6 minus square root 2, and that's all going to be on 4. And that's the way you do it. Okay, long video, but very important.